Next is the representation of spherocylinder or toric lenses. This is kind of the fun part, I think, where you can really um, mess around with the idea of how a toric lens can be broken up into two really distinct pieces. The toric lens that we saw earlier, right, in this diagram, the toric lens is right here. We have the two different powers, two different meridians with different powers. But in this diagram, it was a combination of like a front surface and a back surface, because this is more relating to glasses, like physically how glasses is made, but schematically, like I guess you can say maybe theoretically or schematically, you can think about a toric lens as something that can be divided into a spherical lens again, just like the front surface of the glasses, and a cylinder, meaning like the axis meridian is actually zero and not another toric surface. Um, so, so that's what this represents here. This way of representing a toric lens can also be expressed as a sphere combined with a cylinder. Okay. This is the same image almost, except that the difference is that the cylinder here has an axis meridian at 180, whereas this one had an axis meridian at 90. And because of that, we need to say, well, the power of the horizontal is kind of what you want to use in reference for the spherical lens, because the power of the horizontal plus 0 still gives you horizontal. Hopefully that makes sense. These are practically the same thing, it's just the cylinder has a different axis meridian. But the take-home message is that these powers are additive. They can add the horizontal and horizontal to make a toric lens. This diagram tells us the convention of how we describe the axes, and we kind of describe it from when we're looking at the patient. So we're looking at the patient. That patient's left is 180. Sorry, no, not 180, but it sort of starts at 0, and then it goes in for us, counterclockwise. I guess in the patient's point of view is clockwise. But really, you want to look at it from your point of view as the doctor, as a clinician, from your point of view, which is kind of the numbers go counterclockwise. So here it says give the two spherocylinder forms for the toric lenses shown in the lens cross. Alright, so let's see. I'm just going to kind of redraw this. So this is interesting because we're so used to using horizontal and vertical. Yeah, that's ugly. But yeah, we're so used to using horizontal and vertical, but really the axes can be anything. So I like to have a dotted line. For me, I kind of need, some people can draw crosses without the dotted lines. I always like to have them. So that the dotted lines just represent 90 and 180, and then I'll try my best to draw the appropriate cross that looks, very accurate. The more accurate, really, the better. Okay, so this is a +3. And this angle is 60, right? This 60 degrees from 180, which tells us that this angle Right? If I want to call this angle 60, I can call this angle uh, 150. Right? 60 plus 90, and one is 150. And the power, I'm drawing a little differently from the diagram. The power is -2. So I like to have the axis labeled on one side of it and the power on the other. Alright, so how can I break this apart into the two spherocylinder forms for the toric lens? So we talked about how the toric lens is broken into its sphere and cylinder, or it can be broken into a sphere and cylinder. Right? So the first one is your sphere, and I'm just gonna call this, I'm not gonna be so particular about the images now, but I'll take the +3, right, as my sphere, because I can. Right? You can take either one as a sphere. Then you kind of just calculate it using the math, what the cylinder should look like. Sorry, my mouse is lagging again. But the cylinder should look like what? Remember, we're trying to break this apart into these two power crosses. So +3 plus what gives you +3? Well, that's going to be the 0. And then, sorry, that's a 0. And then +3 plus what gives you -2. So this is where a little bit of algebra comes in. You can write it out. I recommend that at first. Right, you can write it as in to help you really keep track of your numbers. And I see that this is going to be -5. So and this is going to be your first. So, I think that is it. Give the two spherocylinder forms. Yeah. Interesting. I didn't even do this one. My manual's blank. So, yeah. Oh, well, if you want to write wait a minute. Oh, never mind. I'm kind of misinterpreting this question. But this is still really good. This is good practice because you're breaking apart a toric lens into its sphere and cylinder components, and you can do that two ways. So I showed you the first way. Sorry, I mean, I kind of misinterpreted it. This question belongs in the transposition. The two spherocylinder forms is going to be the plus cylinder and minus cylinder form. So we'll get to that later. But this is actually cool because we took a problem and we're kind of dissecting it in different ways. So breaking this apart into its sphere and cyl is this first way, right? And then the second way is using the -2 as a sphere, right? Oops, sorry, I need to draw. If I want to be more accurate, this is a 60, and this is at 150, so -2 and a -2. So what would the cyl be? Well, you want -2 plus what gives you this +3? It's going to be a +5. Because you can see that -2 plus 5 gives you this result, right? We're kind of working backwards here in a way. And then, since it's a cylinder, it's going to be 0. So, these are the two separate forms. This is form number 1. Sorry, my pen is lagging. I wanted to circle the whole thing. And this is form number 2. Okay, and so having those two different cylinders is exactly why we can transpose prescriptions and write two different prescriptions that really mean the same thing, that really mean the resultant toric lens is the same. So we'll talk about that um, in the next video, just so I can keep these videos kind of short.